how many has joined? Okay, 26 has joined. Others are joining. Okay, but till then we will see some review that we have done in the previous lecture. Okay. Uh, in the last lecture, we have started with the TCP, that is the Transmission Control Protocol, and we know that it is a connection-oriented and reliable protocol. Okay, so we also implemented that practical of the socket programming using TCP in the lab. So we know that it is the connection-oriented and reliable protocol. That means we need to go through the three steps, that is the connection establishment, data transfer, and connection tear down if you want to transfer some data. Okay, and it is a reliable protocol. That means if one of the packets are going to be lost during the transmission, we can get the acknowledgement. So that's why we can say that TCP is a connection oriented and reliable protocol. Okay. The services that can be provided by TCP is the process to process communication. Okay, so uh, for example, let's say if you want to use the mail server, if you want to use the file server, then you can go with the TCP, in which you can have a process to process delivery. Second thing is the stream delivery service. In the TCP, your data is converted into form of the bytes, and the bytes are going to be transmitted from source process to the destination process. So we can say that in case of the TCP, we have the stream delivery service. Then sending and receiving buffer. Okay, so to maintain the flow at the sending side and the receiving side, we require the buffer. So buffer is nothing but we can say that some storage location that is allocated at the sending side and same way at the receiving side. So the one way to implement a buffer is to use a circular array that is of 1 byte location. So we can see from the figure that here they have demonstrated one buffer that is of size 20 bytes. Okay, but in real time we can have a buffer that can be 100 or we can say thousands of bytes. Okay, and at the time it can store the hundreds of packets at a time. Okay, but here we will assume that we have this small buffer both at the sending side and receiving side whose capacity is to store only the 20 bytes. So this buffer can be divided into the three parts: the white color, that blue color, and the black color. This white color indicates the location in which the sending process can store the bytes. Okay, so whatever the white block you are seeing, okay, in which the sending process can store the next byte. Okay, while this blue indicates the bytes that are already sent, but we have not get the acknowledgement yet. Okay, so when we can say that our transmission is complete, when we have sent some packet and when we get the acknowledgement, then and then we can say that our transmission is successful. Okay, so this blue color indicates the bytes that are already sent, but we have not get the acknowledgement. That's why it is indicated by blue color. And this black indicates the bytes that are stored in the buffer, but it is not sent yet. Okay, so that is the sending process છે તેણે આ byte ને store તો કરી છે but હજુ એને send નથી કરી. So this can be indicated by black color. Okay, so we have the we can say the we can go from blue step to the blue color to the black color, black to the white color, like that. Okay, so જેમ જેમ તમારું આ જે white color na je block છે okay એમાં byte store થતી જાય તેમ તેમ this white will be converted to the black. Okay, and same way જેમ જેમ acknowledgement આવતું જાય તેમ તેમ these blocks are need to be removed. Okay, so એનો data નીકળતો જાય તેમ તેમ this blue will be converted to the white. That's why we can say that we can visualize this buffer as a circle. Okay, circle of bytes in which the buffer is full, buffer is acknowledged, and buffer is sent. Okay, like that. So by that way, the sending buffer is going to be what? At the receiving side, we have the same buffer of 20 bytes, but we require only the two colors, that is the blue color and white color. Okay, this blue color indicates that the bytes that are already received and stored in the buffer, but has not read by the receiving process. બાઇટ ઓલરેડી આવી ગઈ છે, બફરમાં સ્ટોર થઈ ગઈ છે, but receiving process जो read નથી કરી, so that can be mentioned by this blue color. And whatever the new bytes that are coming, that can be stored in this white blocks. Okay, so by that way, we require only the two colors in which this white will store the new byte and this blue indicate the bytes that are already received and stored but has not read by the receiving process. Okay. Okay, but it is now in real time we are not sending the one by one byte, but we know that on the transport layer we have the unit of the transfer that is known as the segment. Okay, so what is this segment? Segment is nothing but we can say the group of bytes together and creating one packet which is known as the segment. And what the TCP will do? The TCP will add a header to each segment. Okay, so TCP will add its own header. And the header we know that we have so many fields. We will see the next that what is the syntax of the TCP header. So for each segment, it is adding the header and deliver the segment to the network layer for transmission. Okay. So TCP no જે આખો ડેટા છે it is delivered to the network layer. Network layer પોતાનો જે કંઈ પણ ડેટા આવે છે ટ્રાન્સપોર્ટ લેયર પરથી એને IP ડેટાગ્રામ છે જે IP પેકેટ છે એના ડેટામાં મૂકી દેશે and it will add its own header. Okay. Then after that data will go to the data link layer and then the physical layer and then in form of the signal it is going to be transmitted. You can see from the figure that whatever the bytes are there that are combined and it is creating the segment, and for each segment the transport layer has add the header. Okay, it is not it is said that it should not be the equal number of packets in the segment, okay, equal number of bytes in the segment. For example, in the segment 1 we have the 3 bytes, while in the segment number n we can have a 5 bytes. Okay, so it is not like that for every segment we can have an equal number of bytes. Okay, it may possible that for one segment we can have 3 bytes, while for another segment we can have a 5 bytes. So that depends on the size of the message. Okay. It is a connection oriented service. That means we have to go with the 3 steps, that is the connection establishment, data transfer and the connection termination. Like the socket programming, we have seen that we are creating the object of socket class, then using the data output stream and data input stream we are performing the data exchange, and using that close method of the socket class we are performing the connection termination. So we can say that for every data transfer we have to go with the 3 types of phases, or we can say 3 phases, that is the connection establishment, data transfer and connection termination. It is a full duplex communication. That means data can flow in the both direction at the same time. It is a multiplexing and demultiplexing. That means if the multiple processes want to use the TCP protocol, then we require the multiplexing at the descending side and demultiplexing at the receiving side. It is a reliable service. That means we require the acknowledgement before completing the transmission. Okay, whenever we get the acknowledgement of our data transmission, then we can say that our data is going to be transmitted. Okay, so we can say that TCP is a reliable transport protocol. That means we require the acknowledgement for our each and every transmission. Numbering system. Okay, so we have said that for each segment the transport layer has to add the header, as well as it has to add one more field whose name is the sequence number. That means we need to require some mechanism by which we can say that suppose મારી પાસે જો 5 પેકેટ છે, 5 સેગમેન્ટ છે, એમાંથી કયું સેગમેન્ટ કરેક્ટલી સેન્ડ થયું છે, કયું સેગમેન્ટ કરપ્ટ થયું છે. ઓકે, so if you want to identify such thing, okay, કે તમારું કયું સેગમેન્ટ સેન્ડ થઈ ગયું છે, કયું ડુપ્લિકેટ આવ્યું છે, કયુંમાં ડેટા કરપ્ટ થયો છે. So for that we require some identification of that segment. Okay, so we need to identify each and every segment, and for that we are using the sequence number. Okay, the sequence number of the first segment is a random number that is between 0 and 2 raised to 32 minus 1. Okay, so we have seen this figure that let's say one message has one process has created the 5 segments. The segment number 1 has sequence number 10,001, that is the initial sequence number, and each segment is carrying the 1000 bytes. Okay, so we can say that the sequence number for the bytes will range from 10,001 to the 11,000. Okay, so પહેલી byte નો number હશે આપણો 10,001 અને છેલ્લી byte નો number હશે આપણો 11,000 in the segment number 1. બીજા સેગમેન્ટમાં we have the sequence number that is starting from 11,001. Okay, that means we can say that in the segment number 2 પહેલી byte નો આપણો number હશે 11,001 અને છેલ્લી byte નો number હશે આપણો 12,000. Okay, so we can say that if the size of the segment is 1000 bytes, then we can assign the segment number as first one is 10,001. એમાં આપણે 1000 add કરીએ, then 11,001. એમાં ફરી પાછા 1000 add કરીએ, then 12,001, 13,001, 14,001. Okay, so જેટલી મેસેજની સાઇઝ હોય તેટલું આપણે પ્રીવિયસ સિક્વન્સ નંબરમાં એડ કરતા જઈએ તો આપણે નેક્સ્ટ સેગમેન્ટનો સિક્વન્સ નંબર મળતો જાય. Okay, so by that way we can assign the sequence number to each and every segment. Okay, so by that way these algorithms or protocols are going to be implemented. The bytes of data being transferred in each connection are numbered by TCP. The numbering starts with a randomly generated number. One more thing we have to go along with the sequence number is acknowledgement number. Okay, so we know that whenever we send some data or whenever we send some segment, we record the acknowledgement of that segment. Okay, suppose આપણે અહીંયા segment sequence number છે 10,001. Okay, તો 10,001 sequence number વાળું આપણે એક segment મૂકેલું છે તો એનું આપણે acknowledgement જોઈએ. Okay, so we need to identify that this is the acknowledgement of sequence segment number 1. Okay, આપણી પાસે standard ને જે કંઈ પણ acknowledgement મળે છે તો standard પાસે કઈ mechanism હોવું જોઈએ કે then using which it can identify that this is the acknowledgement of segment number 1, this is the acknowledgement of segment number 2. Okay, so for that we require the acknowledgement number. Okay, the sequence number in each direction shows the number of the first byte carried by the segment. Okay, sequence number કઈ રીતે assign કરીએ છે તો sequence number is the number of the first byte carried by the segment, while each party also uses an acknowledgement number to confirm the byte it has received. Okay, so how we can give the acknowledgement number? So acknowledgement number defines the number of the next byte that the party expect to receive. Okay, acknowledgement number આપણે કઈ રીતે define કરવાનો કે receiver ને next જે byte જોઈતી હોય. Okay, so that byte can be given as a acknowledgement number. Okay, so for example here we can say that for the segment number 1, okay, our sequence number is 10,001. So એનો acknowledgement number કયો થશે? Okay, so if the receiver is receiving a segment whose sequence number is 10,001, it indicates that it is receiving the bytes from 10,001 to the 11,000. Okay, so એને next byte કઈ જોઈએ છે હવે? So the next byte it want is 11,001. Okay, so segment number 1 છે એના માટે acknowledgement number 1 કયો હશે? acknowledgement કયું હશે? તો acknowledgement number will be 11,001. segment 1 ના acknowledgement number is 11,001. Same way segment 2 માટે acknowledgement number will be 12,001. Okay, segment 3 માટે acknowledgement number is 13,001, and for segment 4 acknowledgement number is 14,001. Okay, so by that way the acknowledgement number indicate the next byte the receiver want from the sender. The acknowledgement number indicate the next byte it want from the sender. Okay, for example segment 1 મળી ગયું છે, now the next byte કઈ જોઈએ છે તો 11,001. So that's why segment 1 માટે acknowledgement number is 11,001. Okay, so by that way the acknowledgement numbers are going to be assigned. Okay, now we need to understand the format of the TCP segment. So we know that every protocol, or we can say that every TCP segment or UDP segment consists of 2 parts. The first one is the header and second one is the data. Okay, કોઈ પણ protocol જોઈએ આપણે, whether it can be IP, ICMP, TCP, UDP. Okay, that every protocol is divided into the 2 units. The first one is the header, while the second one is the data. What is the size of the header? The size of the header is 20 to 60 bytes. That is same as the UDP or same as the IP. IP has also the same size, same way TCP has also the same size of the header, and UDP has also the same size of the header, that is from 20 to the 60 bytes. And the data can be varied based on the message. Okay. So what we have to store in the header part? So it is said that the first 16 bit can be given to the source port address, that is of 16 bit, and the next 16 bit will be given to the destination port address, that is the 16 bit. Then we have the sequence number, that is of 32 bit. Okay, so third field is sequence number, that is of 32 bit. We know that what is the use of sequence number. So for each segment we require the sequence number to identify that segment, and for that we are using the sequence number. The size of the sequence number is 32 bit. Size of the acknowledgement number is also 32 bit. જે આપણે સેગમેન્ટ મોકલાવીએ છીએ તો એનો એક્નોલેજમેન્ટ આપણને જોઈએ છે. So for that we require the acknowledgement number, that is the 32 bit. Okay. Then we have the header length field, that is the 4 bit. So it will define that what is the size of the header. Okay, so it is same as IP, that if you want to store something in the header length, then if the size of the header is 20 bytes, we have to divide this value by 4. Okay, so 20 ને 4 વડે divide કરીએ, then our answer is 5. Okay, and 16 ને 4 વડે divide કરીએ, then our answer is 15. Okay, so we can say that the value of the header length can be vary from 5 to the 15. Okay, so minimum value that is possible in header length is 5, and the maximum value that is possible in the header length is 15. Okay, so h-line પરથી આપણે header length ફાઇલ header ની length find કરવી હોય તો શું કરવાનું? સપોઝ h-line માં આપણી વેલ્યુ સેટ થઈ છે 5. So 5 ને આપણે 4 વડે મલ્ટીપ્લાય કરવાનું, so that will give you that the header length is 20 bytes. Okay, so by that way, given the header length you can find the given the h length you can find the header length. Then the 6 bit are reserved. Okay, so the 6 bit are reserved for this 6 different types of flags. Okay, so these 6 flags are, first one is the urgent flag, then we have the acknowledgement flag, push flag, reset flag, synchronized flag, and finish flag. So all has its own importance. For example, if you require some urgent byte from the segment, then we have one more field that is known as the urgent pointer. So what it will do, that the first byte will be add with this urgent pointer. Okay, suppose તમારો urgent નો flag set થયેલો છે, that means the urgent pointer છે, that is add with the first byte, and that will give you the one of the byte from the data that the user wants. Okay, so suppose if we require some intermediate byte from the data, then we can use the urgent pointer, and for that we need to set this urgent flag. Okay, suppose જો તમારો data acknowledgement લઈને આવે છે, suppose your segment is coming by taking the acknowledgement, then this acknowledgement flag is going to be set. Okay, push flag. જ્યારે તમે કોઈ પણ data મોકલાવો છો, at that time we have to set this push flag. Okay, so based on this 6 different flags, we can say that આજે તમારું segment આવે છે એનો purpose કયો છે, whether it is for the urgent flag, એ acknowledgement માટે આ segment આવે છે, એ data માટે આવે છે, data માટે આવતું હોય, so for that we have to set the push flag. Okay, suppose we want to reset, that means if you want to start your transmission from the beginning. Okay, if there is some problem at the receiving side and the receiver want to inform the sender that the data is corrupted, but I have not received any segment, so that's why you need to start your transmission from the first. So for that we need to set the reset flag. Okay, then we have the synchronized flag. Okay, so we need to synchronize the sequence number and acknowledgement number from the sending side and receiving side. For that we need to set the syn flag, or we can say the synchronized flag. And last one is the fin flag, or we can say the finish flag. So whenever we want to terminate our connection, so at that time we need to set segment or packet with the finish flag as set. Okay, so finish flag जो आपलो set थतो होय, that it will indicate that this one is the finish packet. Okay, then we have the window size. Okay, so we have seen that we have the sending window and we have the receiving window. So we need to set the size of this window, so that is of 16 bit. We have the checksum that is of 16 bit. Okay, again to calculate the checksum, we also need to include some of the fields of the IP header. જે રીતે આપણે UDP માં જોયેલું, to calculate the checksum, we also need to include some of the field from the IP header. Okay, that is the source IP, destination IP, and some of the field. Okay, that we need to include for calculating the checksum. And the urgent point that we have seen, that if the urgent flag is set, then we require the use of urgent pointer. Okay, then we have so many other options and paddings are there that we can up to 40 bytes. Some of the options and padding bytes can be added, that also we can include in calculation of checksum. Okay, so this is all about the structure of the TCP segment. The value in the sequence number field of a segment defines the number of the first data byte contained in that segment. We know that sequence number so indicate करे, तो the first byte segment is the first byte segment कितनी byte લઈ જાય છે, तो segment આપણી 10,001 થી લઈને 11,000 સુધીની byte લઈ જાય છે. તો sequence number so indicate करे, તો જે આપણી first byte છે એનો byte number. So here we have the 10,001. Okay, so we can say that the value in the sequence number field of a segment defines the number of the first data byte contained in that segment. The value of the acknowledgement field in the segment defines the number of the next byte a party expect to receive. तो पहलू segment મળી ગયું છે, હવે receiver ને next byte જોઈએ છે. So that next byte will be set in the acknowledgement field. So the acknowledgement field defines the number of the next byte that the receiver expect from the sender. Okay, so these are the 6 different flags we have seen. That's URG is the urgent pointer. Okay, ACK is acknowledgement, push is request for push, RST is for reset the connection, SYN is for synchronize the sequence number, and FIN is for terminating the connection. Urgent no use care થાય, the value of the urgent pointer field is valid, then we need to set the urgent flag. Acknowledgement, the value of the acknowledgement field is valid. When we need to push the data, then we have to set the push flag. When we need to reset the connection, then we have to set the reset flag. And when we need to synchronize the sequence number during the connection, then we need to set the SYN flag. And when we need to terminate the connection, then we have to set the FIN flag. Okay. Urgent pointer is a 16-bit field which is valid only if the urgent flag is set is used when the segment contains urgent data. Okay, so it defines a value that must be added to the sequence number to obtain the number of the last urgent byte in the data section of the segment. Data section માં વચ્ચેની કોઈ પણ આપણને એક urgent byte જોઈતી હોય, તો આપણે sequence number માં urgent pointer માં જે value set કરેલી છે, તો તે value આપણે add કરી દેવાની. That will give you the last urgent byte. Okay, so this is all about the TCP header. Now we need to understand about the TCP connection. So we know that TCP is a connection oriented transmission. What is the meaning of connection oriented? That means first we need to establish the connection, then we need to perform the data transfer, and then we need to terminate the connection. That means we can say that like in the TCP, suppose the process has generated 10 messages, so that all 10 messages must be go through the same connection. Okay, if the process has generated 10 messages at the sending side, all 10 messages must be go through the same connection. So that's why TCP is a connection oriented transmission. While in case of the UDP, although the process has generated 10 different messages, that all 10 messages can go through the different paths. Okay, all 10 messages can be go through the different paths in the UDP. While in case of the TCP, all the messages must be go through the same connection. Okay, so that's why first we need to establish the connection, then we need to perform the data transfer, and finally we have to release the connection. So that is the connection termination step. Okay, so first we will understand the connection establishment, then we will understand the data transfer, and then we will understand the connection termination. This is a very important question, and it will definitely going to be asked in the exam, that explain the connection establishment step in TCP using the three-way handshaking. Okay, so if કોમ્પ્યુટર નેટવર્કનું કોઈ પણ એક પેપર ડાઉનલોડ કરો તમે, ઓકે, નેટ પરથી કોઈ પણ એક પેપર ડાઉનલોડ કરો અને એમાં આ ક્વેશ્ચન તો ડેફિનેટલી હશે ને હશે જ, that explain the connection establishment in TCP using the three-way handshaking. Okay, અને સપોઝ ગેટ માટે તમે પ્રિપેર કરતા હોય કે પછી સિસ્કો માટે પ્રિપેર કરતા હોય, તો in that also that three-way handshaking માંથી પણ એક ને ક્વેશ્ચન મેજરલી પૂછાય જ છે. Okay, so that's why we need to understand very carefully the connection establishment in TCP using three-way handshaking. Okay, in our example, an application program called the client wants to make a connection with another application program called the server using TCP as the transport layer protocol. So just see our figure. Okay, so you can see here that this one is the client process, this one is the server process. This one is the client transport layer, this one is the server transport layer. Okay, now your communication start from the passive open. Okay, so first you have to see that we have the passive open request from server process to the server transport layer. That means the server process will inform to the server transport layer that I am ready to receive any connection. Server will inform to the server transport layer that I am ready to receive any connection. Okay, but સર્વર રેડી હોય તો એનું મીનિંગ એવું નથી કે ક્લાયન્ટ એની સાથે કનેક્શન કરી શકે, પણ ક્લાયન્ટની જ્યારે ઈચ્છા થાય ત્યારે જ કનેક્શન કરી શકે. બટ ખાલી સર્વર ટ્રાન્સપોર્ટ લેયરને that server process can inform that I am ready to receive any connection. So that's why if any connection request will come, you should accept. Okay, so that's why our communication start by active open connection. That's why client process, okay, suppose client process is, let's say, our Gmail, and here we have the Gmail server. So that whenever you are logging into the Gmail account, that Gmail account will make a connection with the Gmail server to establish the connection. So that's why for that we require that active open connection. That means that client process will say to the client transport layer that I have some data to send. Okay? Client process will create an active open connection with the client transport layer to say that I have some data to send. Okay, so if the client transport layer has some connection request, so what it will do, it will create one packet, or it will create one segment in which it will set one sequence number, that is the initial sequence number. Okay, we have seen that for the first segment we have the initial sequence number. So let's assume that the client has selected the sequence number that is equal to the 8000. Okay, now we have these 6 different flags, but what is the aim of this segment, or what is the aim of this packet? That it is used for the synchronization. That means we can say that we need to synchronize our sequence number and acknowledgement number both at the sending side and receiving side. Okay, suppose receiver ખબર પડવી જોઈએ કે જે કંઈ પણ પેકેટ આવે છે તેનો સિક્વન્સ નંબર 8000 થી સ્ટાર્ટ થશે, અને ક્લાયન્ટને પણ ખબર પડવી જોઈએ કે જે કંઈ પણ એક્નોલેજમેન્ટ આવે છે એનો એક્નોલેજમેન્ટ નંબર 8001 થી સ્ટાર્ટ થશે. ઓકે, એનો સિક્વન્સ નંબર 15000 થી સ્ટાર્ટ થશે. ઓકે, so for that for first time we are sending our scene packet. So in the scene packet we have set our scene flag, and sequence number we have selected is 8000. We are not sending any data, but we require only the 1 byte that we can use for this sending the sequence number. Okay, so in the 1 byte we can set this value that as 8000, that will inform to the server that જે કંઈ પણ ડેટા આવવાનો છે એનો sequence number 8000 થી start થાય છે. Okay, now whenever one packet is received by the server, what the server has to do, server has to send the acknowledgement. Okay, so server will send the acknowledgement કયું હશે, તો server will assume that whatever it has received એનો sequence number કયો છે, તો 8000. next એને કયું જોઈએ છે packet તો જેની byte હશે 8001. Okay, so what the server will do in the acknowledgement, it will set the 8001. Okay, so what it will indicate, મને 8000 વાળી byte મળી ગઈ છે, હવે મને કઈ byte જોઈએ છે તો 8001. Okay, now meanwhile આ જે acknowledgement package હતું છે એની સાથે સર્વર શું કરશે કે સર્વરે જો ક્લાયન્ટ ને કઈ મોકલાવવું હોય, okay, we are dealing with the bidirectional communication, so server also need to inform to the client that if I am sending something to you, so for that my sequence number is going to be start from the 15000. Server client ને કઈ પણ મોકલાવશે તો એનો sequence number ક્યાંથી start થશે તો 15000 થી. Okay, so this packet is of two types, that is of seen and acknowledgement. So that's why we have set the two flags. One is for synchronizing the sequence number and second is for the acknowledgement. Okay, so sequence number is 15000, that is the initial sequence number that is selected by the server, and the acknowledgement is 8001. We have set the acknowledgement flag and we have set the seen flag. Then also we need to set the size of the receiving window. You will see that in the flow control we require the sending window and receiving window. So for that we also need to set the size of the receiving window. Okay, so we can say that that a receiver can at that time receive up to 5000 bytes. So by that way the server can send to the client that I can store up to the 5000 bytes. Okay, so by that way, by setting the receiving window size, we can inform to the client that I can store up to the 5000 bytes. Okay, now once the client will receive seen plus acknowledgement, then what the client has to do, so પહેલા તો acknowledgement મળી ગયું છે, that means client can know that server has get about this sequence number. Server ને આ sequence number વિશે ખબર પડી ગઈ છે, that means our synchronization task is completed. Then for this seen packet, the client has to send the acknowledgement. For the seen packet, the client has to send the acknowledgement. So as the seen packet આવ્યું છે ના acknowledgement માં, what the client will do, client will send, so sequence number આપણને 15000 મળ્યો છે, that means the client can say that I have received the 15000 byte, but now I want the byte whose number is 15001. So acknowledgement કઈ byte set હશે આપણું 15001 અને sequence number. Okay, so now if the client want to send something, so it can set the sequence number as 8001. So that means now it is sending the 1 byte of data from client to the server. Okay, and this is our acknowledgement. So here we can set the acknowledgement flag and the size of the receiving window. We can also inform to the server that my receiving window size is 10,000. That means I have the buffer that can store up to 10,000 bytes. Okay, so by that way we can say that in case of the connection establishment using three-way handshaking, so we can say that three-way means we require the three different packets. So that's why the name is given as three-way handshaking, and we require the three different packets. The first one is the seen packet. In response we require the seen plus acknowledgement packet, and in response we require the acknowledgement packet. So that's why the name is given as three-way handshaking. Synchronize શાના માટે use થાય? Synchronize packet is used to synchronize the sequence number. So it is using only the 1 byte of data. Sequence number is 8000. Then we have the seen plus acknowledgement. So that means it is the acknowledgement of this first packet plus the synchronization of its own sequence number. So for the sequence number is 15000, acknowledgement number is 8001. We have set the A flag and S flag. Size of the receiving window is 5000. Then we require one more packet, is the acknowledgement packet. That is the acknowledgement of this seen packet. For that sequence number is 8001, acknowledgement number is 15001, and for that we have set the acknowledgement flag. The receiving window size is 10,000. Okay, so in case of the connection establishment, you have to transfer these three packets. Then and then you can say that your connection is established correctly. Okay, જ્યારે આ ત્રણ પેકેટ ટ્રાન્સફર થઈ જાય અને acknowledgement પણ આવી જાય, then and then you can say that your connection is established with the client. Connection is established between client and server. A scene segment cannot carry data, but it consumes one sequence number. You can say that this scene segment is not carrying any data. Okay, we have not any data portion. That means scene segment is not carrying any data, but we require only the one byte that is used to carry one sequence number. Okay. A scene plus acknowledgement segment cannot carry data, but does consume one sequence number. Okay, same way, the scene plus acknowledgement is also not carrying any data, but it is consuming one sequence number that is for the one sequence number that is the 15,000. Okay. An acknowledgement segment, if carrying no data, consumes no sequence number. Okay, if sequence this acknowledgement number is consuming no data, then we don't require any sequence number. Okay, but if it is carrying one byte of data, then we require the one sequence number that is the 8001. Okay, but if we are not sending any data along with this acknowledgement segment, then we don't require this sequence byte. Okay, so this is all about the connection establishment. Second one is the data transfer. एक बार आपको connection established થઈ ગયું, then after we have to transfer the data. Okay, so we can say that at the beginning we have the connection establishment, at the ending we have the connection termination. Okay, so we can say that here ક્યાં સુધી, okay, so આપણને 8001. So now હવે જે આપણી byte transfer થશે, so sequence number is going to be start from 8001. Okay, so you can see from the figure that હવે જે actual data transmission start થયું છે. Okay, so data transmission start થયું છે, તેના માટે પહેલા તો આપણે push flag set કરવા પડશે. Okay, so we have set our push flag. Okay, now what it is saying that આજે આપણું acknowledgement નું પેકેજ હતું છે. આજે acknowledgement નું પેકેજ હતું છે, તો એની સાથે આપણે ડેટા પણ મોકલાવી દઈએ છીએ. આપણો જે પહેલો સેગમેન્ટ નો ડેટા છે, the first bunch of data that we are sending with this acknowledgement segment. Okay, so we can see from this figure that sequence number is 8001, acknowledgement is 15,001, and our data is from 8001 to the 9,000. Okay, if we assume that we are sending the 3,000 bytes of data and each segment is carrying, okay, if we assume that we are sending the 2,000 bytes of data and each segment will carry the 1,000 bytes, okay, from client to the server. Okay, so here we can see that we are carrying the 1,000 byte data, that is from 8001 to the 9,000. Sequence number is 8001 and acknowledgement number is 15,001. We have set the acknowledgement flag and push flag. Okay, same way we can send the another segment whose sequence number is, okay, our connection establishment થઈ ગયેલું છે. So we don't need to worry about any other thing. We just need to send our data. આપણે જે કનેક્શન મળી ગયું છે એના પરથી આપણે હવે ડેટા ટ્રાન્સફર સ્ટાર્ટ કરી દેવાનું. તો પહેલા 1000 બાઇટ નો એક સેગમેન્ટ એનો ડેટા પહોંચી ગયો. Now we'll send our second 1000 byte data, so whose byte will range from 9001 to the 10,000. Sequence number is 9001, acknowledgement number is 15,001. We have to set the acknowledgement flag and push flag. Okay, now once these two segments are received by the receiver, okay, so receiver will assume that I have received the data up to 8001 થી લઈને 10,000 સુધીના ડેટા મને મળી ગયા છે. Okay, we can see that we have received the data from 8001 to the 10,000. Okay, so what the server will do, server will send the acknowledgement. So server ને હવે next byte કઈ જોઈએ છે, તો 10,000 સુધીનું મળી ગયું છે. તો next byte કઈ જોઈએ છે ને, તો next byte it want is 10,001. So in that acknowledgement, the acknowledgement field is set as 10,001. Okay, sequence number is 15,001. Okay, so that means we can see that now whatever the byte that are going to be transmitted from server to the client, so for that, okay, so we are assuming that server is also sending the 2,000 bytes of data from server to the client. Okay, so here the sequence number is 15,001, that is the first byte of this data, that is the 15,001. We can send the 2,000 bytes of data, so that's why the range of this bytes is from 15,001 to the 17,000. Okay, and the receiving window is 3000. Okay. Now આપણને હવે કયો ડેટા મળી ગયો છે? So we can say that we have got the sequence number 15001 મળી ગયું છે, acknowledgement number okay 17000 સુધીનો ડેટા ક્લાયન્ટને મળી ગયો છે. Okay, now ક્લાયન્ટને બીજો કયો ડેટા જોઈએ છે? તો client want the byte for sequence number is 17001. So acknowledgement number is set as 17001. Then after 10000 સુધીનો ડેટા ટ્રાન્સફર થઈ ગયો છે આપણો, બટ એના પછી આપણે કયો ડેટા ટ્રાન્સફર કરવાનો છે? તો નેક્સ્ટ આપણો સિક્વન્સ નંબર છે 10001. So sequence number is 10001. Acknowledgement flag is set because we are sending the acknowledgement packet. Receiving window size is 10,000. Okay, so by that way we can send the data from sender to the from client to the server or from server to the client. So these all things are going to be happen between the client and server, between the connection establishment and the connection termination. Okay. Connection termination using the three-way handshaking. So एक बार आपको connection establish થઈ ગયું, then after we need to terminate our connection. So this can be either done by the client or by the server, but we'll assume that the client will initiate this process. So by that way the client process will send the active close request to the client transport layer. That means whenever the client transport layer will receive the active close connection, active close request, its meaning is now it has to terminate the connection. So now for terminating the connection also we require the three segment, that is the fin segment, fin plus acknowledgement and acknowledgement. Okay, connection terminate કરવા માટે પણ આપણે ત્રણ પેકેટ મોકલવા પડશે. The first packet is for the first packet we can set any sequence number. Let's say sequence number is X, acknowledgement number is Y, and we have to set the two flag, that is the acknowledgement flag and finish flag. So this acknowledgement can be the acknowledgement of the previous data that is received from server to the client, and it is the finish. Okay, so that's why we have to set the finish flag. Okay. Once this is received by the server, the server by seeing this packet and by seeing this finish flag, server can say that this is the packet for the connection termination. So what it will do? It will set the acknowledgement X plus 1. Okay, sequence number X, so the acknowledgement number will be X plus 1, and it is also send one packet whose sequence number is Y, and it will set the acknowledgement flag and finish flag. That is means it is also a connection closing request from server to the client, as well as it is the acknowledgement for this finish packet. Okay, so by that way we are combiningly sending the finish and acknowledgement packet, and at the client side again we have to send the acknowledgement of this finish packet. So we'll set sequence number as X plus 1, acknowledgement number. Okay, so Y મળી ગયું છે, આપણા acknowledgement number will be Y plus 1, and acknowledgement flag is set. Okay, so once the acknowledgement is going to be received, the connection is going to be closed. Okay, so the connection is closed now both at the client side and at the server side. Okay, so the conclusion is at the sending side we have to go with the three steps of connection establishment, three packet of connection establishment, three packet of connection termination, and in between we have to go with the data transfer. Okay, so 5 to 6 slides are remaining that we will complete on the Monday, and meanwhile one announcement is there. On Monday at 10:30 we have the quiz of module 5 part 1. On the Monday at 10:30 we have the quiz of module 5 part 1.